Alright, next let's look at this washing machine homework problem that you guys have due here shortly. Bit of confusion in class, mainly just Mathcad issues, so heck, let's just take some time and I'll set this up on Mathcad and hopefully this will help out. So we got our washing machine removes grease and dirt. First order process, 12% of the grease in the clothes are removed per minute. So we need to find out what that K value is for that particular reaction. So we've got, let's say, time for this one, 1 minute. All right, so per minute, so we'll solve this on a per minute basis. C is equal to, let's just call this 1 for lack of a better term. Actually, that would be C naught. So let's make that C period, and I'll put a 0 equal to 1. And let's go C, that'll be our final concentration, equal to, so we got 12% of the grease. So what would that concentration be that's remaining there? 0.88. Oops, 0.88 would be that value. And so let's go ahead and solve for K. So we use that first order equation, and let's just say given, let's go ahead and give a K value too. So K equal initial guess of 1 per minute. Alright, so given, and then we've got K equal to, and we could actually solve, actually let's go ahead and solve it this way. So given C is equal to, so C, let's use that control equals is equal to C period 0, C naught, times E to the caret minus K times T. Make sure that T value is the same up there that you have before the symbol. Symbology needs to be identical. Let's grab this and drag it down a little bit, and let's go ahead and find parentheses, and let's find K this time equal to, and we've got something 1 over seconds that's there. So let's go ahead and change this to 1 divided by minutes. We want to find this on a per minute basis, and there's our K value. So the very first step is we've got our K value that's there. Let's hit right click, properties, highlight this, and we've got our value that's there. Okay, so now moving to part B that's here, what would be the grease concentration, in milligrams per liter. So the next step is we've got to calculate how much grease is remaining on the clothes after 5 minutes, 5 minutes of time. So we've got some changes that are here. So let's solve this. So T is going to be equal to 5 minutes. All right, and we can go ahead and put concentrations on here if we wanted to. How much? Well, let's solve how much grease is left on the clothes. And our K value is given, so K is equal to, let's just confirm that we've got a K. So 0.17 per second. Let's put per minute. Oops, 1 over minute. Actually, let's go ahead and define this K. So let's delete, backspace. So K is equal to 0.128 per minute that we solved for before. Oops, make sure that minute is there. Alright, and so that little underscore squiggly line, so we already defined that variable, so we're just taking this variable and defining it again, so it reminds us that that variable has been defined previously. Let's see, so our M0, so this is our mass that we had at the start that was on our gene, so M period 0 would be equal to, and this was 0.5 grams. Alright, so 0.5 grams of grease that we have on there. Let's make some room here. And so let's do another given find. Given, and we need an initial guess, but we'll get that next here. So let's solve for the mass of grease. So control equals M period 0 times, so our first order reaction equation, E caret minus K times t. Alright, so all that's defined. We got no errors that are in that equation. Let's go ahead and say m. Let's give that an initial guess equal to, let's say our mass at some particular time is equal to 0.1 grams. Alright, so now let's do a find here. So find, and let's find m, and hit equals, and we got meters per second squared. Alright, so we just want this mass, so we need to probably define this as grams that are here. Yeah, definitely not a meters per second squared, so we've got an error that's on here. 5 minutes, k is what over that time. Looks right. Let's just see what happens if we've got in grams and call that g. Yep, so there we go. So we've got 0.264 grams. Alright, so that's the mass that is left on the genes. And so properties, highlight the region. Let's go ahead and make that nice. And then we can put a text box over here if we wanted to. So you can either do it as inserts, text region. We've got that right there. Mass of grease left on pants at that particular time, or on the clothing, whatever's being washed here. So you can insert text box that are there. So we need to find the grease that is not on the clothes, must be in the water at some particular time. So that's the concentration. So CW, concentration of water, equals that initial mass. So let's say M0 minus M. Alright, so minus M, all this divided by, oops, how do we get that? I think we have a space bar to get expand that. Yep, all that divided by, not that way. So space bar, you can see that little blue line, so you can hit the space bar to expand or subtract the amount of area you want to divide by or incorporate. All that divided by, and we've got a concentration, let's just call that 50, let's call this V for volume. For volume of the water. Now we need to find what that V is. So volume of water is equal to 50 times liters, capital L. So the volume is there. And let's go ahead and solve for C period equals. And we should be able to change this. Milligrams per liter would be that concentration. So it didn't like that that value that's there. Let's see what we can do with that. Nope, I need to actually define what this M term is as well. So let's define that. M is 0.264 times grams. Now that should give us our value. So we've got liters, M naught, 50 liters. M naught was defined up there before. Should come into play here. So let's do this one again. So delete this. Equals alright, we still got some issues with them units here. I think there's an issue with the milligrams that's there. So let's change this to grams per liter. Hit that, and voila, there we have grams. So 4.72 times 10 to the minus 3 grams per liter. Now if we wanted to get that in milligrams, apparently it doesn't recognize the mg. So let me see how to do that. Alright, so what I've had to do here is milligrams is not defined in Mathcad that I'm aware of, so we need to define that. So 1 milligram is equal to mg is equal to grams divided by 1,000. So we have to do that ahead of time. And then I have this equation. So if I wanted in grams per liter, there's 10 to the minus 3 grams per liter. If I wanted this in milligrams per liter, so we can click out and click back in here, and we can change that to, let's just put a milligram that's on here. Hit enter, and we got 4.72 milligrams per liter. So you have to remember, define that term. It recognizes grams, but it doesn't recognize the milligrams. We have to define define what that is. I'll have to look more into the help tutorial to see where those which units are included in that area. So let's highlight this region, properties, and we've got this one done. So thank you.